Welcome to The Explainer. Today, we're diving into a claim that, honestly, challenges the entire language of the universe, mathematics itself. So get ready to have everything you thought you knew about numbers turned on its head. Let's jump right in.
Wow, okay. So right out of the gate, our source material just drops this bombshell. It's arguing that three of the most basic, fundamental pillars of math are, well, built on shaky ground, or maybe not even built on anything at all. This isn't some small academic debate. This is a shot right at the heart of mathematical thinking. So you have to ask, how is a claim like this even possible? In this explainer, we're going to follow the logic here, step by step, to see if there really is a crack in the foundation of, everything we calculate.
I mean, just think about it for a second. The phone or computer you're watching this on, the economic models that basically run the world, the physics that lets us send rovers to Mars, it all, and I mean all of it, assumes that our core ideas in math are solid and true.
And this is the big, provocative question our source is asking today. It's forcing us to stop just taking things like number and infinity for granted, and actually, check the floorboards to see if they're sound.
The whole argument really kicks off with one huge, radical idea: redefining what a number even is. It sounds so basic, right? But the source claims that this is exactly where modern math takes a wrong turn, right at the very beginning.
So how do you fix a problem that big? Well, to figure out what's a real number versus something that just kind of looks like one, the source lays out a really strict three-part test.
And this test, it's actually surprisingly simple. For something to earn the title of real number, first, you have to be able to identify it. Second, you got to be able to tell it apart from other numbers. And third, and this is the big one, it has to be suited for arithmetic. You have to actually be able to do math with it.
And here's the real kicker. If something fails even one of these three simple tests, it gets demoted. It's not a number anymore, it's just a symbol, a placeholder that we've been pretending is a number, but it doesn't actually have the properties of one.
Let's make this real for a second. Take a number like 100. Easy. It passes the test, no problem. But what about a number that is so unbelievably massive that we literally can't compute it or even write it all down? Well, the source argues that that thing fails the test. You can't really identify it or use it in math. It stops being a number and becomes a symbol that just means a really, really big number.
Okay, so if you accept this idea that some things we call numbers are actually just symbols, it starts a chain reaction, like a line of dominoes. And this is where we get to what the source calls the infinity illusion.
We all heard this in grade school, didn't we? It's the simplest argument for infinity. You take the biggest number you can possibly imagine, add 1 to it, and boom, you've got a bigger number. So numbers must go on forever, right?
But wait, here's where those new rules we just talked about come into play. The source says that whole just add 1 idea is totally flawed, because if you get to a quantity that's so big it fails the 3 tests and becomes a symbol, well, you can't do arithmetic on a symbol. You can't just add 1 to it.
So here's the domino effect in action. That redefinition of number breaks the simple proof for infinity. And if infinity is no longer a valid mathematical concept, then the idea of a perfectly smooth, continuous line of numbers, which is totally based on infinity, that falls apart too. It's a total chain reaction.
Okay, this is all fascinating stuff, totally abstract, but it brings up a huge question. So what, right? Does this mean our bridges are suddenly going to start falling down? Let's talk about what this actually means for the real world.
It's the first question anyone would ask, right? After hearing an argument that just yanks the rug out from under centuries of math, is everything we've built on it totally wrong now?
And the answer, thankfully, is a pretty clear no. The source makes it very clear. This is a debate about the deep philosophical foundations of mathematics, not about how we actually use it every day.
In other words, for the engineers and scientists out there, the math they use for their day-to-day work, which is all about measurements and approximations, it all still works perfectly fine. This whole debate doesn't change their results one bit.
At the end of the day, the source's position is that infinity is just a useful concept. It's a handy shortcut. It works because for pretty much all practical purposes, treating something as infinity gives you the same answer as treating it as really, really, really big.
This entire argument really forces us to think about one of the biggest questions out there. Is math something we discover, like a law of nature, something that was always there? Or is it a powerful language that we invented to make sense of the universe? This source suggests that maybe some concepts we thought were discoveries might just be our own very clever, very useful inventions. It makes you wonder, what else do we just take for granted that might just be an illusion?